So variation of electronegativity, variation of electronegativity in groups and periods. What is in groups and periods? So now in groups, what is in groups? Actually, electronegativity is inversely proportional to size. So actually in groups from top to bottom, size what happens? Increases. Size increases, electronegativity decreases. So in groups from top to bottom, from top to bottom, from top to bottom, electronegativity what happens? Decreases because size is increases. So for example, let us consider first A group elements. What are first A group elements? First A group of elements: lithium, sodium, potassium, rubidium, cesium and francium. So now lithium electronegativity values. It is 1.0. It is sodium is 2.9. So 0.9. So then potassium is 0.8. Rubidium also 0.8. Cesium is 0.7. Francium is a radioactive element. So what happens? Electronegativity values decreases down the group. So wherein potassium electronegativity is equal to rubidium electronegativity. Okay, next one. Variation of electronegativity in periods. In what is periods? So actually electronegativity is inversely proportional to size. In periods from left to right, size is decreases, then automatically electronegativity values increases. So from left to right, electronegativity what happens? Increases because size decreases, nuclear charge increases. So for example, let us consider second period elements. What are second period elements? So now second period elements. What are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So neon is noble gas, its electronegativity almost 0. So then lithium electronegativity is how much? 1.0. It is 1.5. It is 2.0. It is 2.5. So then it is 3.0. It is 3.5. 3.5. And fluorine is 4. What is fluorine is 4. So then what happens from left to right? Its value is increases. What happens? Its value is increases. Okay. So then lithium to fluorine increases. So then halogens with highest electronegativity values and alkali metals with lowest electronegativity. So it is the low electronegativity. It is the high electronegativity. What is high electronegativity? Highest electronegativity, lowest electronegativity. Okay. So now it is the variation. Now applications. What is applications? Applications of electronegativity. Actually based on the electronegativity to decide the metallic, non-metallic and metalloid nature. And find, what is a find the nature, find the nature of metallic, non-metallic, and metalloid. What is metalloid nature? Electronegativity. Same as electronegativity as well as electron affinity also. So now second application is, if the electronegativity difference between two atoms, electronegativity difference between two atoms in a molecule, electronegativity difference between two atoms, electronegativity difference between two atoms is greater than 1.7, the bond nature is ionic bond. The bond nature is a ionic bond. If the electronegativity difference between two atoms is less than 1.7, it is a covalent bond. It is a covalent bond. If the electronegativity difference between two atoms is equal to 1.7, 50% is ionic, 50% is ionic, and 50% is covalent. 50% is a covalent. So it is the main applications of the electronegativities. Okay. So then, if the electronegativity is more, these are the non-metals. If electronegativity is less, these are the metals. Okay, metals. It is the electronegativity. So now, next concept is valency and oxidation numbers. What is next concept is valency. What is a valency? So what is valency? Valency is the combining capacity. It is the combining capacity. What is a combining capacity? Actually, valency is always not constant. It is changes from one element to another element. So valency is a combining capacity, or it is the valency is the number of hydrogens. What is number of hydrogens? Number of hydrogens are twice of the oxygen atoms. What is it? Twice of the oxygen atoms. Twice of the oxygen atoms is called, what is valency? Is called, what is a valency? So now actually valency in groups is constant. In groups valency is constant. It means remains the same because same electronic configuration. Because similar electronic configuration. But the valency is changes in periods. In periods, valency changes. Because dissimilar electronic configuration, because left to right atomic number increased by one unit, then the valency is changes. So for example, valency. So now NaH, valency of sodium is 1 because it is combines with how many hydrogens? 1. So the valency of sodium is 1. For example, MgH2. MgH2. So magnesium valency is 2. Magnesium valence is 2 because magnesium attached with 2 hydrogens. How many hydrogens? 2 hydrogens. So same as MgO. What is MgO? What is the valency of magnesium? 2 because number of oxygens 1. So then twice of the oxygen atoms. Twice means 2. So then it's valency how much? 2. Actually valency is equal to number of valence electrons. Valency is equal to number of valency electrons. Number of valency electrons. It means it is similar to group number. What is it? It is similar to group number because number of electrons are similar to group numbers. Group numbers. Okay. So now highest valency shown by highest valency. What is the highest valency shown by what is ruthenium Ru, rhodium Rh, sorry, ruthenium. Second one is osmium and third one is xenon. Highest valency shown by ruthenium, osmium, xenon. The valency that is 8. What is it? That is 8. 8 is the valency. So valency may be 0, 1, 2, 3, 4 up to 8. No combining capacity, its valency is 0. Best example is noble gases. Noble gases combining capacity is 0 because these are the stable with octet configuration. That is with octet configuration. So it is simply valency. So now next concept is oxidation numbers. What is the next concept is oxidation numbers. So then oxidation numbers